Okay, office hours. Welcome to office hours. Um, I have a couple activities and things to do. Um, I think we'll give a little bit of time for anybody else to get here. And I'm looking at just how the game Yahtzee works because I'm thinking, well, maybe let's try to build some parts of this sort of live today, in addition to doing some review and just trying some other things out and then answering any questions. Um, right off the bat, I mean, Karen, we talked a little bit during the study group yesterday, so um, if you have any other questions that come up, just drop them in the chat, of course. Um, I guess every time I change tabs, it's going to tell me you're presenting to everyone. Okay. And let me just make sure we are streaming. Good. Okay. So uh, I think I'm gonna hold off on doing the review slides a little bit, and let's um, just tinker with some other stuff. Maybe give some people some time to get in here. I've been looking at okay, JavaScript simple dice roller because I don't want to do this the wrong way, and we you probably want to use the random function, and you want to divide it into six, right? If let's say we're gonna make a virtual die, which could return 1, 2, 3, 4, 5, 6, and each of those has an equal chance of happening. Oh man, this is a full-on HTML, CSS. You can roll dice and you get a number 6. Gee, I'm not sure if this is mathematically sound, but basically, this math.random function. It's always going to return a decimal number. Um, that is between 0 and 1. So it could technically be 0 and it could technically be 1, but because there's so many possible um, numbers that it could be, like every decimal that the floating point bits can possibly represent, it's going to be very unlikely that it would ever be either of those. So in general, you're going to get a decimal number which is between 0 and 1. It'll have a lot of decimals usually. And what they're doing here to get this to turn into a 1, 2, 3, 4, 5, 6 with equal probability is to take that random decimal. They multiply it by the number of sides they want the dice to have. In this case, it's 6. And then we're doing two things here. We're adding one, and we're doing the floor of this, which is a special function, which is the same as like when we were talking about convert to int. Um, it just throws away the decimal part. So it's if it's a 1.2, then the floor is going to be 1. And I think it's pretty much the same thing as telling it to parse int. It'll do just about exactly the same thing. I don't know if there's cases where it won't, but this is a mathematical function that you might be familiar with in any case, and that's what it does. And then you add 1 because, of course, it's going to be 0, 1, 2, 3, 4, or 5. It's really hardly ever going to be 6, again, because we have this thing is hardly ever going to return 1. So I think they're just ignoring. I don't know if it actually can ever return 1. I've definitely never seen it, and it's vanishingly improbable. So maybe they're just ignoring it and saying, well, it probably won't ever return 1. So this won't ever, the floor here won't ever actually be 6. So they're adding 1 to it. So 0 becomes 1, 1 becomes 2. And then they should all happen with equal probability because all of the possible decimals are, they're split into 6 sections roughly. By multiplying by 6, um, we're basically redistributing that even random distribution between 0 and 1 out into an even random distribution between 0 and 5.99999, it's assuming, and then chopping off the decimal part and then adding 1. And that should split it up into 6 buckets pretty cleanly. So if we want to, let's try this out, I guess. I'm going to make a new folder here for some stuff from today. I'm going to call it Yahtzee. It's not going to have a complete Yahtzee game in it for sure, but we will be able to do some experiments here. Okay, and if we do math.floor, oh sorry, let's just start with math.random, and let's console log this. So I'll save this. It's the only thing it's going to do. Log some random decimals. I'm going to do no, sorry, we are outside of the Yahtzee folder and outside of my folder. So we need to do first cd Gus cost, and then again cd Yahtzee. And now we can see we're in the right folder where our file is. If we do node index, we will see in this case it was pretty high. This would have been a 6 because it's in definitely in the 6th partition of all the decimals between 0 and 1. This one's very close to 1. If we do it again, obviously this one's very low. This would be a 1. And so forth. I mean, it should be evenly distributed. You know, any number is as likely as any other. So if we add sorry, I'm going to break this up into 2 lines so we can sort of cleanly look at one line and the other. So I'm going to paste what I copied there. Const number equals, and then if we log number, we should see the same thing. 1 second. Okay, so I'll just double check we're still seeing the same thing. I have this big, I don't know if anyone can see this, but I have this flag saying it's sharing my screen, so I have to move that. Okay, if we run this, we'll get the same exact result, but now we can mess with this and then worry about logging it separately here. So if we do this times 6, we're going to get numbers that are between 0 and 6. And they're all 3 right now, but you know that one's a 0. Point something, you know, so they always have a bunch of decimals. If we wrap this whole thing, so now we have a number between 0 and 6 is this expression, and every time it'll be different, of course. If we wrap this whole expression in a call to math.floor, we're going to be passing the result of what this expression evaluates to math.floor, which is going to chop off all the decimals. So if we run this a couple times, we'll see 0, 3, 2, 0, 3. Okay, yeah, there's some other numbers in there. 5, there's a 5. Okay, so we should get up to 5, 0, 1, 2, 3, 4, 5. 6 different numbers, but they start at 0, so that's why they're adding 1 here. And that will give you 1 through 6. 6, 6, 1, so forth. Now, for our dice game, like, we could definitely just show the numbers. That would be fine, and I guess that's what this page is doing. But let's just check real quick. We might get lucky. Is there Unicode dice? Because this is what we did for the cards. And if we could find some symbols, that would be pretty cool. Well, there is a dice emoji, it looks like. Oh, wait, miscellaneous symbols. Let's see if we can get all 6 symbols from a die. My computer might slow down a little bit because I'm doing a Hangout and streaming. Let me just check if no one else is trying to join yet, as far as I know. Double check Slack. Okay. Here's some symbols. Whoops. Let's check die. Cool, there it is. Look at this. We have 1, 2, 3, 4, 5, and 6. So wherever you look this up, there will usually be a printed out. You can usually highlight this, and it'll copy, something. And then if you paste this into your code, you're going to get a little dice symbol. The modern computers didn't used to do this. You'd get an empty square or something because it would say, this is some kind of character, but I don't have all of these fancy, extra character sets installed. But Macs pretty much support just about everything, and almost everything does these days. So you have emojis, you have these symbols, you have foreign characters, everything. So we can do that. We can copy that just like we did. So we could say above everything else, because this will be a constant we might use everywhere, and we'll name it like the suit. Remember, we had the suit symbols object, which stored the Unicode symbol for each suit. We can call this dice symbols. And then this will be an object, so curly brace there. We'll put a semicolon at the end so we don't forget. And what this could be, now this could be an array. No, this could be an array. Because an array, the indexes are all numbers. So it depends on whether we want to say our dice game has if the indexes of our dice, we're like, okay, we'll start at 0 like normal. So a 0 is a 1, a 1 is a 2. When you turn it into a die, we could do that, and we could just have an array with 6 things, and then we use the index to grab the dice number that is 1 greater than the array index. We could absolutely do that. But in this case, let's just say, why don't we put the human numbers? So we'll say 1 is string, so I'll make some quotes here and paste the 1 die. And we can do this exactly the same way. We can copy each of these out and so forth. Remember, I noted though that this is somewhat controversial of a thing to do in the real world. So if somebody's working in a terminal, or if they're working on a server, if you have some of this code somewhere and you're trying to work with it, and you are on a computer or in a terminal or in some context where there aren't symbols provided, you could easily find yourself, or a colleague could easily find themselves in that kind of situation. So if you put a bunch of symbols, well, just because they work on the Mac and just because they work in VS Code, it doesn't mean they're going to be as universal or as reusable as they could otherwise. So that's why I do this as a shortcut sometimes. I've done this in real programs to just put little icons and things because it's so much quicker than just figuring out how to draw something, or the alternative, which we'll do here, which is, you can see how there is this number here, and then there's this other number, and they're all for each dice symbol. And if we scroll up to the top, we can see that there's a Unicode number and something for HTML. So you can drop this right here in HTML, I think, next to your paragraphs and whatever, and that will show the symbol, I think. But we're interested in the actual Unicode. So if we copy this number, this is what's called a Unicode code point. And as you can see, this one's hexadecimal. These have E's and F's, and they're not just numbers. They are base 16 numbers, like we showed on the first day. If you copy just this number, this is the actual like position in hexadecimal in the Unicode standard where you can find the die symbol, and these are all numbers. So if you put these in your program, nobody is going to not be able to look at that. Now it's going to be there that you might want to put it in the die symbol here. You might want to put in a comment, maybe, because then even if someone can't display it, they won't get the helpful comment, but you won't have to look at all these numbers and wonder what they are. But we copy this 2680, and in order to make it not print, so if we said console.log to here 2680, we will remove this one. This is all valid. We're not getting any red squigglies, so we should be able to run this just for an example quickly. If we run this, we'll see the characters printed out, of course. How do you make this say, well, I want to type these in, but I want it to understand this as the special character that's the same as if you just pasted this symbol when it prints it out. But there's a special way to do that, and that's, remember we did backslash things. We did backslash T for a tab character. There's a backslash U, which lets you do Unicode. And see how it's highlighted all of the numbers after it. Hi, who's, wait a minute, someone's trying to, hi, Kate. Karen's here. We're starting our office hours. It's all streaming on YouTube and will be saved there, so you can catch up with the beginning. I've been starting by doing the just some playing around with random numbers, and we're gonna try to make some dice, sort of like we made cards before today, as sort of a little activity. But I'm gonna go through a review. We could do that. We could break from this in a little bit and go through a quick review and then come back to this. But I'm explaining how we have these same symbols that we had for the card suits. You can find the same symbols for dice. So here's a 1. If you can see, it's very small, but you can see these are little dice. And I'm explaining that there's 2 ways to, I guess I can't really, oh, here we go. Yeah, my computer's going very slow because I'm streaming and chatting and all that. You can paste these in like normal, but remember I explained that like some people don't like this. So there's an alternative way to do that, which is to take a special number that we look up, which is on, it's usually right next to the symbol when they're listed out like this. It's a U something. And you can copy this as an alternative into JavaScript. And the whole thing turns red to indicate I'm understanding all of this as one special character. So I think if we log this, we'll see instead of these characters like this, all printed out, we actually see the 1 die, and we're actually able to refer to it by this. And importantly, your colleagues probably won't get mad if they're working on a computer that doesn't have all of these dice installed. I mean, Macs have pretty much every character installed, but some older computers, terminals, some places don't, so they wouldn't even be able to see this if this is in your code. So I think this time I'll leave a comment here to show this is the 1 die, but we'll copy in these /u, and then I think they might just count up from 80, 81, 82, and we'll just put these in as the dice. 2, 6, 8, 1. That's the 2 die, and we'll do 3, 4, 5, 6. And this object will we will look up a number. The keys for an object can be a number, they can be a string, they can be anything. So we can actually put numbers in here, which are 1 through 6, and what we get back is a symbol of the die with the face that we're looking for. So if we go down to here, and we do console.log dice symbols 2, now this is not an array index. This is a object index, and this is probably too confusing, I'm realizing. Maybe we should just go back to make it an array where it's 0 through 5, but the human displayed versions are 1 through 6. And this is another, every time you do something like this, you're like, well, the users expect numbers to start at 1, and this is always a problem. But let's say we did 2, it should match the key 2, which is also a number, and this should print out whatever this becomes, which I think is the dice 2. So there's the 2. Let's get rid of this confusing object with number keys. This is far too confusing. Let's change this to be an array with just the Unicode things in order. And some people say, well, you should leave a comma at the end of here. Even though it's the last line, it'll let you put an extra comma with nothing after it. And when you break it out on lines like this, one of the recommendations is often to leave that there, just in case you want to put more things after it. You don't have to add the comma every time. And it's harmless, so you can do that. So now if we log dice symbols and we've just made this change, we're actually going to see the 3. Because now we're using array indexes and not object keys where we wrote them all out. So we're going to need to basically not do this +1 logically and then display all the dice as 1 through 6, but think of it as 0 through 5. That might be, in fact, the easiest way to do this. I know it's very disorienting, and it's just a thing that will stay slightly disorienting. I mean, you get better at just sort of thinking about, oh, I'm in the context of an array, so you always start counting at 0. You kind of get good at just seamlessly doing that, but you do mess it up every once in a while, and it's just something you got to deal with. So if we get rid of this, we have, Kate, if you go back and look at the beginning, this function returns a random number between 0 and 1, and it's a decimal, so it's 0 point something something usually. We're multiplying it by 6 to turn this into a random number between 0 and 6. And then we are taking the floor of that, which is the greatest integer less than or equal to this number. So what this does is it chops off all the decimals, and we end up with 0, 1, 2, 3, 4, or 5, we're pretty much never going to see 6, because I don't know if this can even return a 1 exactly, and there's so many possible decimals that you could get that it's vanishingly unlikely even if so. So we use this to basically get an integer, and we're going to get an even distribution of all of the numbers on the dice, because they should be evenly distributed between 0 and 1. Now they're evenly distributed between 0 and 6, and then we're throwing away the decimals, so we get all the boundaries of this are each integer. So 0, 1, 2, 3, 4, and 5, they're all evenly spaced in between the 0, or everything's evenly spaced. We should get them all with even probability, which is what we want from a dice. So in order to show that, we can log the number, of course. And we're going to get 0, we're going to get 2, we're going to get 1. We're never going to get 6 pretty much, or anything other than 0, 1, 2, 3, 4, 5, but we should get them approximately evenly. if we want to show the dice face, instead of logging this, we would log dice symbols number. And this is going to, again, convert the 0 into a dice that says 1, the 1 into a dice that says 2, and so on, because this here has array indexes. So regardless, what we're going to get is dice rolls, individual dice rolls, and they should be, we're not seeing a whole lot of high dice rolls, but they should be random. So they definitely should be in there somewhere. There we go. And hopefully we'll see a 6 eventually, just so I know I'm not doing this wrong. Come on. There's a 6. All right, that took a while, but we finally got lucky. Okay. So this is, how you would use dice symbols and work with dice. Something that approximates a dice is much simpler than something approximates a whole deck of playing cards. Now, of course, um, we have to do multiple dice and we have to start managing them kind of like cards. But one die is a very much simpler than a deck of cards that you deal, because it's just 6 possible numbers and they're just random, and effectively you transform this random distribution into the dice random distribution, which is what's called discrete, because it always gets forced into one of 6 buckets. It's not just a continuous decimal like this originally is. And we do that with the floor. Okay, I think I'm gonna go. Is that all good? How's did that was that helpful or anything? Yeah. Okay. I'm gonna assume yes, and it is streaming. So okay. Thank you. Okay. So let's go back to presenting, and let's do some slides which are just some review of terms, and let's do some examples and post any questions that you have along the way, anything you want to see in more detail. Let's for sure pause and do that. Okay, so okay, here's my slides. This is office hours. We will do a review of some terms. So the first stuff is sort of the very basic computer concepts, the things we talked about the first day. A bit is a binary. It's something that can only have 2 values. It's a 1 or a 0. It's on or off. You can call the values whatever you want, but there's only 2 of them, and they reflect at some level or along the way somehow they're going to be translated down all the way down through machine code and executed by the computer by actually flipping little electronic switches on or off. So that's how the whole computer works, is by, at the very, very lowest level, everything is switches flipping on and off. And those become, we represent those eventually by talking them as bits, which have a 1 or 0. We do math with them, we combine them together so that many bits can all be combined into many possible values, and they can start representing bigger numbers and then strings and then everything from there. A byte, when you hear about a byte, all that means is 8 bits together. It's a common grouping, partly because um, early computers executed on groups of 8 bits at a time. So they were called an 8-bit computer. Um, there were 16-bit computers. Most computers these days are 64 bits. I believe pretty much almost everything new is a 64-bit computer. That includes cell phones and everything. Um, And then um, what happens is once you have all these bits and you set them in different positions and you want to sort of use those positions to do something, you have to basically assign, like the computer doesn't understand that these switches mean anything. But when we're using computers, we need to basically say that a group of bits in some context has a meaning. So when we say that a group of bits is a number or a group of bits is a string, the computer is still just flipping them on and off and doing whatever we tell it to without understanding what it is, of course. But when we say that a group of bits has a meaning and then we represent that and we write tools, programming languages, and things which make it easy to work with numbers or strings or whatever, then we have what's called a value. So a value is, this here is a value. Now, this is a weird one because it has this special magic sequence in it, but, 2 is a value. And the value is always the thing over here on the right-hand side of what's called our assignment operator. So we'll do the operators in a second. But the value is, you see it as a sequence of characters here, but inside the computer, what this sequence of characters is telling the computer to do, telling JavaScript to do, and that whole sequence of events, is to flip some switches into the positions that basically represent any of the information we need to put or that we are concerned with. And then, the computer does that, and it also stores probably a sequence of bits which say that this is supposed to be a string, but it doesn't know what a string is. It's just more settings, more bits. A variable is the other half of our expression here. When you have a value somewhere and you assign it to something, that's called a variable, and it's very similar to a variable in algebra. It's a name that stands in for some kind of value. And there's a interesting kind of like confusing part here because we talk about immutable variables and mutable variables. Well, in the math context, when you're doing algebra and you talk about variables, the whole point, as people explain, is that x can be 5 or x can be 6 or x can vary between different things. But that sounds sort of like a process, and in the programming context, we talk about a variable which is immutable, which basically means it can't vary between different things. Um, the variable can still refer to anything one time. So I guess it's still technically accurate in a sense to say that this name can vary, but it doesn't. If it's an immutable variable, it doesn't vary while the program is running, right? It could vary between programs or between runs of the program, perhaps, but not while the program runs. Um, if it does vary, if it does change or be reassigned, there's a technical problem here because we'll see the reference a value and reference kind of messes with this because the variable doesn't vary, but other things inside of it can kind of, and that's an unfortunate additional complication. But if you're talking about an immutable variable, it won't be reassigned. So the outer, whatever it's originally refers to, or whatever the value is that it's originally assigned to, it's not going to be assigned something else later because it you can't reassign it, and that's the way you achieve that is by declaring it with const. Mutable can be reassigned. You achieve that by doing let. Um, Type is basically a category which tells you how you're supposed to interpret the bits in a value. So when we say, well, we wanted a value to be a number, we wanted a value to be a string, the concepts of number, string, array, those options, those settings, that's called the values type. And that's like some additional data off to the side. It's some metadata or whatever, which is, the computer can understand that because it needs to sort of provide different functions on different types and different things like that. But it's just how we're going to be interpreting the bits in the value, and that's bits are bits, but based on the type of your particular variable. So it's a variable is what has the type. Actually, no. Well, it's complicated, but the bits don't have the type. The type combines with the bits to produce some kind of meaning or to interpret those bits. Um, when we talk about types, there's those reference types. We'll go over those in a second, but the reference itself is a special kind of thing, which it doesn't really have a type. It doesn't really have a value. There's no such thing as a reference value in JavaScript because it's all kind of implicit. It's all kind of automatically done for you. You don't have to manually say, I want to reference over to some bits over here. But a reference is some bits which actually just locate or point to some other data. And that's what we're working with when we talk about references, reference types. It's not the data itself directly. There's this sort of hidden step in the middle where you're working with some way to locate other data. So this one is a tricky one. Let's actually pause for a bit and then come back to this. But let's do a couple demos with just variables. I'm going to comment out all of these things so we don't log our dice. But we can do a little bit of stuff at the end of our script. And we'll say const x, const my word equals, I don't know, what's a good word? Green. Okay. So what we're doing here is we're saying, first of all, this part here is a literal, it's what's called a literal value. We are instructing the computer that some bit somewhere should exist and should be arranged in a pattern which can be interpreted if through the right sequence of steps as a sequence of letters, and those letters will spell out our word. All that this is doing is going to say, okay, I understand there's a bunch of bits somewhere. They are arranged in such a way that will be a sequence of letters. That makes it, together with that value should be sort of bundled with some metadata, which says this is a string. So if at any time later you want to look at those bits, you know how they're supposed to be translated or arranged so that they can be interpreted. We take this value, so this section here, and we use our assignment operator to say, take all of this stuff, all of these bits, and make a new concept, a new word in our program. In our program, in the context wherever this shows up, the scope, we'll do scope, but wherever this exists and is a thing, we're going to have a word which all of this data, these bits plus the type, is assigned to. And because we're using const, we're saying this is the only time in this scope or this context that anybody should be allowed to take anything and directly assign it to this particular word. We're making this word an immutable variable, which has been assigned now and can't be assigned again. So if we try to do my word equals red, we get an error. So if we scroll up, it says assignment to constant variable. This already exists. It's already constant. We're trying to assign it again. And we're not supposed to, the point of using const is to make the computer understand that nobody is supposed to do that. So it will stop you and it will refuse to continue if you try to do that. It's sort of a way to safeguard against future mistakes. If we make this a let, it's not going to error. It's not going to do anything because we're not logging it, but it'll at least finish running. And if we console.log my word, of course we're going to see red because by the time we get down here, we've already assigned it again. If we log it before reassigning it, of course, we're going to see green and then red. Okay, so that's what mutable and immutable are. When we get into the value and reference types, they have different behavior. So this is a very tricky thing because we just did a demonstration where we are assigning values to variables, and there's const and there's let, and const basically guarantees when you're talking about a string, it basically guarantees that that string is not going to change. That if anytime you go back and look at that string later, it will be what you originally set it up to be. And even if you try to change it, elsewhere, the program will just refuse to run rather than change it. So that's all true with a value type. You have a lot of guarantees, and anytime you assign the value, so even when there's a let, and you assign it again, a new copy is always being made. So you're always you have some guarantees about every time you assign a value to a variable, if you don't assign another value, either by preventing it with const or just by not doing it, you're guaranteed that the bits that you originally had assigned at the to be that value are going to be the same, are going to stay the same. You don't get that same guarantee with a reference type, with an object or an array. When you assign an object to a variable, you're assigning a way to locate some data. You're not assigning the data itself. And when you copy or assign to the same thing to a new variable, you're not, like with a value type, you're not assigning a copy of all of that data. You're assigning just a copy of the way to locate the same data. So that's risky, and that's a problem because let's do the demo again just to review this. We have here we have my word equals green. We have let my other word equals my word. Now this stands for green now because we've assigned green to this variable. When we say I want to let my other word equals my word, well, this stands for green. So we are assigning the same value that we assigned to my word to my other word. But what that means, because we are assigning by value, because it's a value type, because it's a string, it means that we're taking the actual value here, the actual bits, all of the bits which are used to represent the letters in that word, and we're making a copy of them. And we're saying, all of this data, which is this, but a copy is now assigned to here. Because each one needs to refer to, sorry, I shouldn't use the word refer. This is a problem I've had before. But each one of these variables should be assigned to the same data, directly to the same data. And to guarantee that each one sort of owns its own data and is reliable, or you can understand that it is going to be assigned directly to that data, a copy of the data will be made. So if we do this, assign a value here to my word, we assign whatever this is to my other word, we've copied all that data and we've assigned it to a second variable. And if we say my other word now equals red, we're allowed to do this because we have a let. We can reassign either of these. But what it's done is made a brand new value and assigned that to our second variable. It hasn't overwritten any of the data because each of these, it's throwing out the original, data that was assigned to my other word. It's saying, okay, this no longer has that value. And JavaScript will go automatically and go clean up those bits, and it'll say, okay, you're not using these anymore. Those bits which were arranged in the pattern for green are gone. But there was a copy made. So at the time you assigned it here, you made a copy. So these ones are still fine. So if we do console.log my word, it's still going to be green. So that's what happens with value types. This is because the variable assignment is the process of directly linking some data to a name. And when you assign a new variable, you assign new data, which might be the same pattern, but it's new actual data somewhere on the computer, and it's owned by that variable in a sense. So you are actually copying it, and it's sort of safe to modify one of them, and the other one will not be altered. A reference type is the opposite, like we said. The thing you're assigning is not the data itself. It is a way to find that data. And because a way to find that data, if you copy that way to find that data, you're going to find the same data because it's a map. It's like if you had, it's hard to do analogies for this, but it's like you have a treasure chest and you have a map, and if you make a copy of that map, you haven't made a copy of the treasure, you've made a copy of a way to find the same chest. So whoever uses the map and goes and gets the chest first, it's going to be gone when the second person goes to get the chest. And that's what happens with, let's say, an object. So if we say my object equals word green, so console.log my object.word, we're going to get green here, of course, because that's what the object is like. But if we assign my other object to whatever my object is, what we're assigning is not all of this data. What we're assigning is a way to find this data. It's the reference to this data. And because we're making a copy of that reference does not mean we're going to find different data or modify different data. We're going to find the exact same data because the place where we're locating it is the same. It's a copy of the reference. So if we then change, of course, my other object dot word equals red. Now if we log my object dot word, it's going to be red. So that's object or value versus reference. You have to watch out when you are assigning references or reference types, objects and arrays especially, because making copies of them is not as simple as just assigning to a new variable. And unfortunately, const, because of this whole reference thing, const does not help you here. So even though we change both of these to const, it's still okay with this because these variables, we are only assigning each variable once. So it's still like, okay, you are not ever reassigning either one of these directly. What we're changing, what we're reassigning is a string that's a string value inside this object. And because they're references, that doesn't mean either one of these change. The location of this data is the same. The location hasn't changed. You know, the logical location, the place to the way to locate this data hasn't changed. We still have the same reference to the same concepts or the same place in the computer, but we've changed what's at that place. And const does not care about that. All const cares about is, are you changing the actual thing assigned to here? Well, no, it's a reference, but it's not changing. So const is okay with that. And that's a problem because, you know, it doesn't help you at all. We're still going to end up with a mutation of what's inside the object, even though we tried to make it constant. All you get, you know, the only thing it will make constant is the reference, which is a problem. Okay, so that's is there any, if there's any other questions about reference types or value types, post them in the chat. Okay, let's go over some this concept of an operator. So there's different kinds of operators, and they're classified by how many things they operate with. So a binary operator is these ones are all, you know, the assignment itself. This is a binary operator, and it's called that because there's two things on either side of it, and it operates on both of them. So binary means, again, two things, and every one of these operates on two things, one of which is on either side of it. So this, we've gone over this kind of extensively. It assigns the thing on the right to the name, the variable on the left. Or sometimes a reference, which is a problem. The plus operator adds numbers, and it can also concatenate strings. So again, if we do my string equals hello plus world, we have a space in here. The plus here is going to put the strings together. Just stick them right together. And we get one string that says both. This operator will work just as well on numbers. Of course, this shouldn't be called my string anymore, but we'll just run it. We get 2. It will try to coerce, what it's called, change the type of either side to get them to stick together. So in this case, it can't convert this into a number, but it could convert this into a string. So the string wins, and this is going to end up being altogether a string, which has hello and then 1 converted to a string. The multiplication doesn't work like that. There's no way to multiply a string in, or at least JavaScript doesn't think so. So when you try to do this, it's going to say not a number. The only possible thing it can convert both of these to, in order for this operator to make any sense, is numbers. So it tries to, and this one is not a number. It becomes this special, really tricky value called not a number. And then because not a number sort of propagates throughout your program. Every time you end up with a not a number, every time you combine that with something else, you try to multiply or divide or whatever, you're going to get more not a numbers just every single time. And all of these, the star, which is multiply, the slash for divide, and the subtract, if you try to use them as binary operators on a string or anything that's not a number, you are going to get not a number. Okay. So these here are for Boolean logic, trues and falses, ones and zeros. This is when you want to operate on individual switches and individual logical cases of true and false. And let's go into a couple of examples of this, just because I think I sort of skimmed or did this a little bit quickly and didn't really realize that Boolean, all of this concept of switches and bits, and then you apply it to logical stuff. If you didn't take a logic course or something, it's not going to be it's not going to make natural sense, or it's not going to be familiar to you. So let's do a little bit of time on bits, booleans, true, false, and the operators that you use. This and or are the primary ones. So let's see. Okay, so we have a variable here. We'll call it is above freezing. And that's true because it's actually not freezing today. It's very nice. Um, we're taking this true, which is a special type of Boolean, and we are assigning that value to our variable called is above freezing. And if we have another one called is sunny, it's not sunny today. So we have it is above freezing, but it is not sunny. And this is how you would represent sort of a logical truth or falsehood, um, and then you start combining things like this in order to basically make your program decide to do things one way or another, or whether it's finished or not, or anytime it has to make a decision, you can sort of reduce that decision, a two-way decision, into some kind of logical construct, which is either true or false. So if we start using this operator and we say const is kinda nice, we would call it maybe kinda nice if either it's above freezing or it's sunny outside. So we'd say is above freezing or is sunny. And this is going to be true. So if we console.log is kinda nice, this is going to be true because it's above freezing, and that's enough. Either one of these is enough for it to be kinda nice. If we do another thing, and you can probably guess is really nice, that's if it's both above freezing and it's sunny, then it's really nice. So if we log first is kind of nice and then is really nice, we're going to see it's kind of nice, but it's not really nice. True and false. Um, let's do a little bit of that string interpolation to make this. Remember this: if you do backticks on a string, you can make a special kind of string. Sorry, my Alexa thing just tried to talk to, or tried to understand, and I just said it again, so watch. Nope. No. Nothing. Okay. Hi, Elizabeth. Hey, we're doing some review. We're reviewing some terms. There's quite a bit before this. It'll be up on YouTube because it's still streaming. So just uh, you can grab it from the beginning if you want. And we're going to try to do a little bit of work to make a dice game, sort of like we made a card game with some dice symbols instead of card symbols, like that, and some random numbers. It's very simple to do dice with just some random numbers. So we'll get back to that, but we're doing a review of some basic terms right now. Um, and right now we're doing Boolean terms. So we have operators, assignment operator, the plus operator, and the and the or for Booleans. And I was just going through the explanation of what Boolean stuff is. I kind of wanted to do a very just straight through of Boolean, true, false, logic, stuff like that, because I think that's one of those things I didn't really spend a lot of time on, and it's something that's unfamiliar probably. Do you know? Can you talk,
Who?
Elizabeth? I think everybody else is muting.
Oh, yeah, I can.
Okay.
Can you hear me?
Yeah, I don't know if the stream will pick it up because it might be like, but if you do a question, I'll like repeat it probably or something like that. So does that sound good?
It does. Thank you.
Okay. All right. So this is what we did, for example, for Boolean logic. We have these special cases called true or false. They translate, ultimately down at the lowest level down to switches being flipped on or off. So one true might might be represented by one switch being on, and the false might be the switch being off. And you can, when you're telling the computer what to do, to branch, it's called the if and the else, or telling it to do one of two different things, or any kind of decision it has to make that has two possible outcomes. You're going to be probably reducing that all of the logic down to true and falses, and working at that level. So this is something that a logic course, or discrete logic, it gets very complicated. You can do algebra with true and false and things like that. But the basic idea is that you name you assign true or false values to different things, and you can call them. These can represent something that makes sense, and that has consequences in the real world. Like I made a variable called is above freezing, it's true today, and is sunny is false today. So if we want to combine these and we sort of make a conclusion about is it kind of nice out or is it really nice out, we can use the and the or to start combining these. If we say, well, I consider it kind of nice out if it's above freezing or if it's sunny, then you combine them together like this. And because one of these is true today, then this whole thing is kind of nice is going to be true as well. So when we log is kind of nice, we get true. Because we've combined them with the or, it is above freezing, or it's sunny because it's above freezing. If we do a similar thing where we say, is it really nice out? Well, I only consider it really nice if it's above freezing and it's sunny out. And so you put this and operator in between, and this does, it has a similar consequence. This is only going to end up evaluating or being assigned true. This side is an expression which will only evaluate to true, which will only be reduced down to a true and then assigned if it is above freezing is true and also is sunny is true. And because one of them is not, this does not end up being true. So we see a false. The one thing that we didn't really look at all, the normal way these are taught in school, we can look at what's called a truth table. And this is sort of how you in the abstract represent what one of these functions does. And you can make big, truth tables which have all kinds of other logical combinations, and you can do algebra on them to sort of compute logical combinations of logic. And in some cases where something is too confusing for you to understand in your head and to sort of translate yourself, you can write it down and you can manage it like this. But in a lot of cases, this sort of stuff is just implied. It's something you just sort of understand. Like, well, it's when I described in English, it's not sunny, but it is above freezing, and either one of those means it's kind of nice. You can kind of follow along with that. Once it gets more complicated, maybe something like thinking like this will come in handy. So these are some unary. So we're not talking about unary operations, but they say, oh, true itself is a unary operation, which is kind of interesting. That's but here's whoa, yeah, okay. So this here is a giant one, which is way oversaturated. So here's what I'm talking about. If you say this is, let's say this one is, it's kind of sunny, or it's sorry, this one is, it's above freezing. This one is, it's sunny. So above freezing, sunny. If we want to say it's really nice outside, it has to be above freezing and sunny. So this symbol is how you do and in like traditional logic, I believe. And this what's called a truth table is basically it's like a way to read across. When this is true and this is true, then this one is true. If either one of these is false instead, and the other one is true, it's still going to be false. And if both is false, it's false. So this lists out basically explicitly all four possible combinations and then the result. And um, this should make quite a lot of sense. It's very simple to sort of look at, and you probably understand this kind of implicitly. But as if stuff like this gets bigger, and this is how you can sort of manage it, and as like one of these a table or a matrix or whatever. This is the same one for or. You'll see in this column there's three cases where it can be true and only one where it can be false. So it's sort of the opposite. All of the places where, no, it's not the opposite, but when they're both true, it's true. When one is true, it's true. When the other one is true, it's true. But if both of them are false, then it's false. Um, Logical implicate. Oh man, this is, I don't know what most this means, but there's a bunch more logic stuff, and it gets not and exclusive disjunction. Not man. I don't. You're not going to use any of this, but here is here is another way that you see truth tables for the and the or. So the headings here are the two, the row heading and the column heading are the two things you're combining. And the value when you look up the cell that they cross, that's the value you get out of the operator. So this is the and, false, false, even though this one's true, false even though this one's true, but true when they're both true, right? And the or, false in the corner here, but true if any of the other ones are true. Either one is true. So that's what sort of Boolean operators are, and I think the other thing is that every binary operator, like I just want to reiterate, every binary operator combines two values into one, and that's what it does. So when you're talking about an expression which looks like this, it's not one value yet, but it will be one value because the thing in the middle is going to operate on two things and combine them into one. Okay, so let's finish this string interpolation thing. We're gonna use our backticks here to print nicely the two results of our checks here. Is kind of nice, and then we do $sign, and this brackets. We drop our variable right in there. Now we could drop this right in here too. It's just as good. We could drop our variable. We could drop an expression, which will reduce, again, this will combine them into one thing, and then that's what will print. It'll be the same result because we're just doing it in two steps here. We're combining it and assigning it, and then we're using the assign. And we'll do the same here. So if we run it, we'll see is kind of nice, true, is really nice, false. Okay, I think I need a short break. Is how's everyone doing? Let's let me see how much stuff to review is left. Elizabeth, if there's any particular subjects that you want to go over, I kind of wanted to go over that short circuiting with the OR. One more thing with the OR operator, and then we'll do some stuff about scope and maybe like functions and a little bit of review of that. But if there's any subjects that are confusing in particular, and then after we go over all that, we can do a little example where we try to simulate some of the aspects of the game Yahtzee. We're not going to do a whole full game all the way through, but we'll simulate some dice rolling and just how to organize that stuff, just as a little exercise. And I think that'll be it for today.
Sounds good.
Okay.
And a break is cool because I can get coffee because I just woke up.
Sounds good. All right. Well, we will pause and break, and I'll be back in about 10 minutes.
Cool.
All right. Okay. So we have a couple more subjects to go through, and we will cover those a little bit, and then work a little bit on a like a way to represent the Yahtzee dice game in JavaScript. Okay, so we just went through our binary operators. They combine two things into one, and an or are the ones which are work on Boolean. It's called values, true and false. Let's do a little bit more about with this. Um, if you so this is something that happened during the class, and I didn't really notice it fully or go into why it was happening. And I think this might have been confusing to some people. One thing about JavaScript is, it tries to make any kinds of types work with whatever it's doing. It will try to convert things for you because it thinks it's being helpful, and sometimes it is. But this has some strange, surprising results. If we change, instead of having, let me make sure I'm streaming. Okay, we're live. If we have this value assigned to is sunny, and right now it's false. What if we change that to a 0? So is above freezing is true, is sunny is 0. Doesn't make a lot of sense, but it will run. What we're going to get when we try to log this stuff is kind of nice is true, because it's figured out, well, I already saw a true here. I saw a true right away. It checks them in order left to right. So because one of them, the first one that it checks is already true, it's good enough, because we looked at our truth table. There's no possible way that this could not be true, because one of them is. So it doesn't even check the is sunny value. It doesn't care that it's 0. It doesn't care that it's false. It doesn't even know what it is, or it doesn't operate on it in any way. It just says, we're done, return this one. This becomes true. If we do the same with is really nice now, we need to check both of them, because they both need to be truthful. So it's going to check this. It's going to say it's true. Okay, we can continue. But then when it checks this one is false. It's not technically false. It's 0. And that evaluates to false. So, or not evaluates to false, but it's what's called a falsy value. So in JavaScript, certain values which are not themselves true or false will function like true or false when they need to be. So 0 is what's called falsy, and a 1 is what's called truthy, because then you could use them as bits in a sort of a binary sequence. You could have 1s and 0s, and they would stand in for trues and falses. Any other number, though, that's not 0, like 600, that's truthy. So everything other than 0 is truthy. Kitty, get out of here. The cat is trying to eat my snacks. Okay, so anything other than 0 that's a number is going to be truthy. The thing that you're seeing here, though, is we're not seeing true or false. We're seeing the number 0. So if we put a 1 here, we're not going to see true. we're going to see 1. But we're still going to see true here because it checked it first. It doesn't even look at what this number on the right is. And this kind of is an unfortunate or a very tricky part. I was gonna add a. Are you kidding me? All right, Kitty. Sorry, 1 second. Kitty, the kitty's gonna have to go in timeout. I'll be back in a minute. Sorry about that. Anyway. The and the or do this logical operation. They do it on trues and falses. They try to do it on anything else by looking at the truthiness or the falsiness, which is, what it ends up converting into. The problem is that sometimes, you want it to be a true or a false, and it's not going to convert. So when this thing runs, it's going to check the left-hand side. It's going to say, I'm going to move on to check the right-hand side. And it's going to say either, okay, it's true or false or whatever. But it doesn't convert. It ends up returning, as you can see, what's on the right-hand side. It ends up returning the 1 itself or the 0 itself. So this operator by itself does not convert the values themselves that are truthy or falsy into true or false directly. The operators, both of these, just return whatever it needs to return, and it sort of passes it along and says, well, you could keep using this in more Boolean true and false operations, but I don't want to convert it to true or false because there's a couple of places where that's convenient. And it is convenient, and let's do a couple of those demos now, but it is weird to see that what you get back is not true in this case. It's the 1. Let's say this one's false, right? Now, what's going to happen when we change this first one is that in this case, it will check the first one, and it will say, well, that one's false, but the whole thing could still be true because this one, either one, is good enough. So it will move on to check, is Sunny? And that's going to say, oh, it's 1. It's true, but who cares? It's going to return the 1 because it did check this. In this case, it's going to say, well, the first one is false, and then there's no way possible that both of these are true because this has to be both. So it's going to return the false. So we kind of have the opposite effect here. So when it is kind of nice, we get back our right-hand thing, which is truthy, but it's not true. And in this one, we get back the false, and we ignore this one because there's no way both of them could be true. And this is used in some places, and the example I gave was somewhat different from the example in the book, and I think there's two important kind of or there's several ways to use this to do things, to do shortcuts, and we'll just type out a couple here and look at them briefly, and then let's move on. So let's say we have a let. Let's say it's what should we make this one about? How about we've said let chosen candy, and that's undefined. We're not going to initialize it to anything. And then what we're going to do is to say uh, uh, if something unpredictable. So we're going to use math.random here like we did earlier. But instead of, for doing dice, different numbers on dice, we're going to use math.random to just possibly run something and possibly not run something. And we'll give it about half probability by doing that. So if the random number between 0 and 1 is greater than 0.5, we'll do something. Otherwise, we won't. Now this, in general, this is a risky thing to put in the logic of your program because like anything else, it doesn't run predictably. In a sense, it's sort of a side effect. It's going to run differently every time. It depends on some external random number generator. And that means your program will be unpredictable in a way. So, just watch out for that. But we're using it just to stand in for anything else that's like could go either way, and we just want a quick way for it to go either way right now. So if something happens, and if it happens, we're going to say chosen candy equals, let's say, m and m z. So this becomes a string. And this is, I don't know, the user is choosing a candy. I don't know. This is strange. But what we're going to do is say let down here. Or no, we don't need to declare it again. We already have chosen candy as the variable, the name. We can update this to say, real quick and really easily, if there's a string in here, if there's anything inside this string, that becomes a truthy value. So that becomes something where when you start combining it with these Boolean operators, it will work just like a true will work. So we can say if there's something here, then this is going to be true. So we can put an or here, and we can put a default. We can put something that it should end up as if this is falsy, or if this is empty string, or if this is unassigned, which is all of those are falsy. So we say chosen candy equals chosen candy, or the default will be something healthier, which will be dehydrated apples. That's a kind of candy according to some people. So we can have that be the default, and if you don't choose, opt for something else. And then we log. So hopefully this still makes sense, but we're using the or as a way to sort of check a value and do something if it's not true. And in my example in the class, this was possibly we run a function. You could run a function here, you could evaluate any expression you want here, but you can use this to assign a default or to perform some kind of default action if something is not present or if something evaluates to false. You have to watch out that this really is a falsy value. If we'll do another example in which it's bad in a second. Okay, so in this case, this did not end up greater than 5, and we never assigned this. So we ended up on this line. Well, this is false. So this whole expression evaluates not true, but the actual value, the dehydrated apples, which is truthy, but it's not converted to a true or false. And then we end up assigning that result to our variable. So in that case, it was greater than 0.5. This example really makes no sense, but I hope it conveys, what what you would use this in this case for. You don't always know, whether there's something here. And this is sort of a safe way to say, have a default, make sure it has something, assign it to itself or a default. Um, the So the problem is, uh, you have to watch out that your value can never be a falsy value if you're doing this. If we say this is chosen index, let's say someone is choosing an array index and they start at 0. So let's say the chosen index they choose 0. You can't do the same thing here because we make all of these chosen index. It 0 is falsy. So it's never gonna, even if they've chosen it, even if this has been assigned 0, um, it's never going to be satisfied on this side of the OR, and it's always going to assign 5 over on top of it, no matter what. So that's a problem. You have to watch out if you're going to use this for default values. But when you see something like this, when somebody says, assign it to something or something, that's a way to put a default in place of it. Sometimes you can do the same thing with the and. Um, in order to only have this value be used, be overwritten or be used or whatever in the case where this is true. It's the opposite thing. And the and is more often used to check something first and then run a function if it's true. The or will check something and then run a function if it's false, essentially. So that's the effect of, because of the way that the order in which it tries to combine the Boolean things, you can cause different behaviors to happen. And that's all that is. Okay. So there's other kinds of operators. There's some operators that only work on a single value, and we looked at the not, which is an exclamation point. It converts any truthy value into false. And these are all truthy values. A positive number, an empty object is a truthy value. And a true, of course, is truthy. And then any falsy value, false itself, a 0 number, or an empty string is actually falsy. So this empty object, probably because it's a reference, so this is probably because there's still a reference somewhere, that's truthy. And then this one is falsy. And all of these get converted into true, and all of these get converted into false. So this one doesn't have the same kind of thing. Like, it's not like the and or the or where, if you do false or 6, you get 6. It does not convert the 6 into a true. The not always converts into true or false. There is no, it never ends up as the original type. It always ends up as Boolean type. So you can do console.log not 6. That's going to be false. You can do console.log not 0. That's going to be true. And this means that we can double it. We can flip. So because not, it flips it once, you can flip it back. And this is the easy way, a common way sometimes to explicitly say, I want to take a truthy or a falsy value and convert it into what it is, whether it's true or false. So if you do not 6, 6 is truthy, you're going to get true. Because it's converted it the first time and then it's flipped it back to what it was. If you do not empty array, you're going to get true. If you do not empty string, you're going to get false. And, this is a weird looking, there's not a whole lot of reason you just do this like this. but sometimes you'll use this as a way to check as a way to assert, like in an if statement. Let's say you have some user setting, const user setting equals, and it could be anything, but in this case it'll be a URL to myspace.com slash super cool person, their profile page, or something like that. If you wanted to check whether this exists, and do something based on whether this exists, and that's all you want to do with it, and you know that it's a string, there's no way to accidentally have this be truthy unless there is characters. Any non-empty string is truthy. So if it's not empty, you know that it's truthy. You could do an if not user setting, which converts this into false first and then true first. So this explicitly converts it into a Boolean. Do some stuff here. But this won't have any different effects. This won't behave any differently. But this is sometimes used to sort of indicate to yourself and to other people working on your code that all you care about here is the truthiness or falsiness, and you want to be explicit about that. So you put the not there. Okay. So that's not. You can do a plus without anything on the left side of it. That is a unary plus. You can actually use plus and minus as ways to basically convert something into a positive or negative number. And I'm not sure. Can you do this with a string? Yes, you can. So this is sometimes used just a plus in front of something, especially strings. If you want to try to convert that into a number, but you don't want to run parseInt and you want to be real fancy, you can put a plus there instead. A minus will convert it into a number and then I believe negate it, so it will make it -5. Yeah. Now if you do minus and then the string says -5, I believe it becomes 5. And if you do a plus and the string says -5, it will be negative. So plus is a way to say, like, convert this thing into a number and do nothing else. And minus is a way to say convert this thing into a number if necessary, and then negate it, make it the opposite of what it is. So I don't think I really touched on those during the class, but those are other kinds of unary operators. And then there's this type of operator. You can change a value into what type it is. Type of, and then you do a space, and you can say 5. This is going to print number. You can do type of this 5. This one is going to say string, and so forth. Now, type of thinks that an array is an object. That's one fun thing about it, because technically, at the very earliest stages and lowest levels, an array is just a kind of object. Now, instance of. Okay. Let's see. Is this how you do it? Yeah. So there's another binary operator that I just alluded to, that my colleague texted me about when I was saying array is an object, and they're like, no, array is an instance of array with this capital A, and apparently an instance is a way to say it's whatever kind of objects have different kinds, and those are called instance of this or that, and the empty array is an instance of an array, and the empty object is an instance of an object. So when you get more specific about like not only what is the type, but what is it an instance of, there is a and I think once you get into maybe some prototypes or class type of stuff with JavaScript, there is a further specification of all of these are objects at the lowest level, at the type, what's called the type level. But beyond that, types can be instances of this or instances of that, and there's actually a difference between the array at that level, at that more specific level. So this is an instance of an object. Uh, I guess number must have it. I don't know. This is not, definitely not. Number? Is that a thing? I don't know. That doesn't work. So number is a type. Oh, maybe it's the string number. I don't know. Whatever. Yeah, whatever. Instance is like more specific. Like what kind of object is this? Not just that it's an object, but I think maybe everything that's uses instance of has to be an object. But so type of is a unary operator because it only, you do type of 5 and you get number. It only has one. It only operates on one thing. Instance of is apparently a binary operator because you have to do thing on the left, instance of, and then what you're checking whether it's an instance of on the right. And that's it. These are some unary operators. They operate on one thing, type of this thing. Okay, there's one thing, the ternary operator, which operates on three things. And it's called the ternary operator, which means it operates on three things. There is a condition here. Whoops. This whole expression is the condition. You put the question mark, which is the first part of the ternary operator after that. And then this middle part is what the whole expression should evaluate to if this condition at the beginning is true. So this could be an and or an or. We're doing a greater than here, which is checking the value, comparing the number values. And then there's a colon, which is separates the last two parts of the ternary. And then the last part is what the whole expression should evaluate to if this is false. So we have condition, we have if true, evaluate to this, if false, evaluate to this. And then the whole thing will evaluate to one of these two. So if we take this is like literally a way to do a coin flip because we're checking if a random decimal here between 0 and 1 is greater than 5.5, and we're going to evaluate the whole thing. The whole thing will become heads if it is and tails if it is not. So every time we evaluate this expression, because we're running math.random here, it might be either one. It works just like a coin flip. So that's that. Okay, that's the ternary operator. Let's look at scope a little bit and function, and then maybe a little bit on functions. Every variable has a visibility, or like it has a place or a scope. It has a purview or a certain area of the program where it is relevant. And some variables are only usable or visible inside functions or inside functions inside of functions. You can nest functions inside of functions. Some are only visible in an if statement or one time through a for loop, as we saw with the one place in our card trick. Both let and const will be scoped to whatever the closest block is. So that's any curly braces anywhere. And they could have a while loop, it could be a for loop, it could be an if statement, it could be a function. All of those are going to be contained and will define the scope of every let and const variable that's inside of it. A var is older, and this one is only going to be scoped to the closest function that contains it. So only functions will create new scopes for these. When you're looking, or when you want to use a variable and you're inside a function, you can see outside that function. So you can, if there's a variable scoped outside your current function, as far out as you need, all the way out to global scope or whatever, you can see that variable. You can refer to it if you need to. Nothing outside, though, will be able to refer to use your variables that are inside the function. Now, if you define a new variable with the same name inside the function as what's outside the function, you're sort of overwriting that name, and then you can no longer see the one outside the function. But that is, if you don't do that, you will be able to see everything that's outside your function. And in general, the guideline is that, if a variable doesn't need to be outside of a function, if you never use it outside of a function, don't put it outside of a function. And the same for an if statement or any other block. If you don't need to use it outside a particular place, just don't what's called pollute the global namespace, or don't put a bunch of stuff that can be referred to from anywhere in your program, but which is not useful anywhere in your program, because you only have a certain number of names for things, and as a program grows, you might need to use a common word like counter or URL or something that is used many, many times in many places. You might want to reuse that name in many different files in many different places, and you definitely don't want them to be colliding. If each place where you use the variable web page or URL or whatever is separate and is scoped separately, then you can safely say, I don't need a big, huge, long variable name, and I can safely call this one URL, which is convenient, but it won't be risky. It won't overwrite anything else. Okay, so let's just do a little bit of demonstrations of scope stuff and function stuff, and then let's do a little bit of Yahtzee stuff, and then I think that'll be it for today. So we define a function like this. It has some arguments, so we'll say is above freezing, is sunny. And we will return so this is sort of back to our example. Rather than just declaring this once and assigning it, we can take this piece of logic and reproduce it. Anytime we ever want to check, is it kind of nice outside, we just have to tell it if it's above freezing and if it's sunny, and it will return the logic that we want it to do, to combine those. We need to say true and false. So this function returns true because we've passed it true for one of them in the aura value. It's just like before. Now, there's a thing that happens in the spring in Syracuse and in anywhere that's cold, and I don't know if you've noticed this, but you're so used to it being just incredibly freezing, um, where uh, you will think that it's really nice outside when it's only 50 degrees or something, because you're so sort of you're so used to it being just freezing that you're meant to, something mental or something physical, or I don't even know, you get tolerance to the cold throughout the whole winter, and then the first couple days when it's anywhere above 50 degrees, you just feel it feels so warm, it feels like you don't even need a coat. So there's some like uh, there's some kind of like state or something that stays that basically gets preserved and is you carry along with you, and then that might affect it as well. It might not just be an objective thing that because it's above freezing, then it's this nice or whatever. It could also be how your state of mind. So we're gonna say um, const uh, how uh, how used to the cold am I, and we'll say this variable should store what you consider the word freezing to mean. I mean, I know it means literally the point at which water turns into ice, but let's say I'm so used to cold weather that let's rename this. What do I call freezing? And we'll say freezing is anything above 20. Sometimes you're like, this is pretty nice because you're so used to it being 5 degrees or whatever. And let's change our parameters here. So instead of just saying whether it's above freezing, our first parameter will be temperature. Okay, and our second parameter is sunny. That'll stay a, a Boolean. So we define inside the scope of our function something here called what do I call freezing, um, or let's say what I call freezing. It's a There's a grammatical name for this. It's a noun or something. But it's the number 20 because 20 degrees Fahrenheit is what I call freezing at this time of year. Now we don't have this one anymore. We have to say temperature temperature is greater than what I call freezing, or is sunny. And that's kind of nice. So we're gonna say it's not sunny, it's still, we're passing false as the second parameter here. But for the first one, we're gonna pass 27. Well, because we have defined what I call freezing to be 20, that is, the temperature is greater than what I call freezing, so it's kind of nice. That's what we'll get. Now, if internally I change this to be 40, because maybe it's September and you're not used to freezing, um, then it's going to be false. Now, this is being used, and this is going to be being combined with some other variables. So we could let's first say const current temperature, and let's make this one 27, and let's put current temperature in here. Const current is sunny, and that's false. And we'll use these names instead of um, just the literal values in there. So we have current temperature, we have current is sunny, we pass them to our function. This inside it just defines something else. And then we return according to our logic. Is the temperature above what I call freezing, or is it sunny? And we get the same result. Now, if we try to log out here, if we're like, well, I want to know what I call freezing, this is not going to work because it doesn't know what we're talking about. We're outside this function scope, and we're trying to refer to this name, but we're out here. And to the outside world, this name doesn't exist at all. So that should make sense, that this is scoped to the function. It's only usable, or it only really exists in the context of this function. If we do the opposite here, and we say, well, let's put these up here, it doesn't actually matter. This you'll probably learn about something called hoisting. Like, it doesn't actually matter what order, but if we say do the reverse in here, console.log current temperature, we can see the log will happen. It will be able to look out. Is there anything called current temperature in here? No. Well, go outside this function and do the same. Is there anything called current temperature? And there is. So we'll be able to see it from inside the function. Okay. So let's go a little further with this, and let's combine this for one more example. Let's combine this with some things about closures. Remember, we talked about closures, and they're very confusing. What they, and let's just extend this a little bit to do some stuff and to use this fact that stuff is scoped to this function, and let's change this a little bit more. So let's say, okay, here's this is just a pure function. It's called a pure function. It has no side effects. It makes something inside it, but it doesn't. It's independent of everything outside it, and it doesn't affect anything outside of it. And when you pass two values in here, the result is entirely dependent on the two values you pass it, and nothing else. So this is it's called a pure function. It's very safe. It has no memory in a sense. It doesn't keep anything inside it that's like hidden and or logged to the console, or interact in some way that's not completely obvious. Let's do this. Let's remove the name. So this is now an anonymous function. Let's wrap the function in parentheses. And let's run it right away. This is what we were calling the immediately invoked function expression. We define the function right here. We make sure it's an expression by wrapping it in the parentheses. And then we run that function right away. And this is going to evaluate. All of this will evaluate down to one thing, because this will return something, and we need to put some arguments in here, because see, we are running this function, and this function expects two arguments. So we would need to put current temperature and current is sunny right down here as arguments. But if we said const is kinda nice, we'd run it once, and we'd get that value of this whole thing, defining the function and then running it immediately with these two values. We'd get all of that, and we'd assign it to is kind of nice. And if we log, we're going to see true, false, because you call 40 freezing. And that's, that's not 40. And it's not sunny. Same exact result. But we're doing it, we're not defining the function and then calling it whenever we want. We are defining an anonymous function expression, calling it once right away, and assigning that to our constant. Now let's try this. Let's try remove the arguments. So we don't have any arguments in our function here. And this is we're gonna change this a little bit. We'll still have a what I call freezing, but instead of just returning just a number or a true or false here, and this is the only thing that our function returns, we're going to return a whole object full of functions. So let's return an object. And let's make it so that we have another function inside of here. Is kinda nice. And this takes temperature is sunny. And this, I'm going to paste what I cut. And this will do exactly what the whole thing did before, but it's an inner function. Well, we're going to say our object has a key called is kind of nice, and that value is our function. That's this. Now, first of all, we need to rename this. This is confusing because this is no longer just a function called is kind of nice. This is kind of like a whole system, and we're going to call this my temperature feelings. Okay. So my temperature feelings is going to end up being what this returns, because we're calling this anonymous thing right away. So my temperature feelings will be this object. This object will have something called is kind of nice, and that's our function that does this computation by comparing with what I call freezing, which is in here. It's all inside. It's all wrapped inside this this one function, the outer function, and that that basically means that this is a closure in the sense that we're closing over this variable. We're keeping it forever, basically. And anytime we want to run this, we'll refer to what this was. Now you can go even further than this. You can say put an underscore here, because this is a nice convention. When you're using something inside, and when you just want it to be, I would maybe ignore this. And I'm sorry, like if this just kind of goes off the rails, you can feel free to we're doing some pretty advanced stuff that we didn't do last week, but we'll put an underscore here, because this is inside our function, and that's a pattern you do. And we're going to make one more function. We're going to call it function. Inside here, we're going to make something called change what I call freezing. So this is what happens over the course of the year. You get used to cold weather, and you start calling freezing colder stuff. And then you get used to warm weather, and you start calling 50 freezing. So temperature. And you just pass this. When you want to change what I call freezing, you pass this a temperature. And this is going to update. It's actually going to change what I call freezing. And because it's going to change, we have to make this mutable. We got to be able to change it. So we're going to say what I call freezing equals the temperature we give it. And then because we want both of these to be accessible or usable, we need to return this inner function from our outer function so that it becomes something we can use. Sorry, this is called change what I call freezing. Okay, so we have this inner variable which is closed out, which is sort of owned by and kept by this function. Um, and we have inner functions that we're defining to change this, which actually reach out to this scope here and change what it is to a new temperature that we give it. And then we have our function, which was the whole thing before, which is we are checking whether it's kind of nice based on a temperature and whether it's sunny. And it compares, again, the temperature we give it with this thing that it owns. And then it's either that or is sunny. And then we return both of these functions inside an object. So when we do all of this, then my temperature feelings is going to be an object which has these two functions. But the functions, I mean, look at this. The functions have all kinds of interactions with this value, with this thing that's in here, which, as you can see, like you can't look at that value. You know, if we go down here and we say, I want to see what the value of this is. Everywhere else in the program, this doesn't exist. This is not defined because you're outside of the scope where it was defined. But if we say my temperature feelings dot is kinda nice, and we pass it 30 and true or false. It's always false, I guess. So it's all dependent on the temperature. But if we do that, it's going to say it's false because it remembers what this is and it's able to compare it with it. So let's remove this tricky immediately invoking thing, and let's just say that this outer function is called get temperature feelings. So whenever we run this as many times as we want. It has a name again. Whenever we run it, though, it's going to start. It's going to set up a new inner what I call freezing in a new scope, and it's going to remember that, and we'll be able to use that by calling this, and we'll be able to check that by calling this, and we're going to get back from this function a whole API, really. We're going to get a whole programming interface that allows you to work with these temperature feelings. So we can do const Gus's temperature feelings equals get temperature feelings. And then we'll say const Karen's temperature feelings equals get another temperature feelings. So let's say, you know, I've been on vacation or something. I missed the spring, and I don't really understand that freezing is 40. I think freezing is 50. So we could say Gus's temperature feelings dot change what I call freezing, and let's give it 50. And Karen's temperature feelings, I mean, it starts at 40. Every time, every one of these starts at 40. So we actually don't need to do this. But mine have changed, right? So we say is kinda nice, and we give it 45 and false. and we log it. We're going to see I don't think it's kind of nice because we've changed what I call freezing, and we've closed over this whole value here is closed over, and it's sort of internal to this whole system, and we have no way of looking at it directly from out here, but we can change it and we can actually rely on it in this logic. It still exists somewhere. So we're going to see a false here. And if we do the same with Karen's temperature feelings, because we haven't changed what she calls freezing, that internal thing, we're going to see false and true. And that's really what, that's exactly, that's why it's because we've closed over this value. It's because we've kept it away somewhere. It's this remembers initializing this back when we originally got both temperature feelings. It remembers initializing this. The inner parts of it can see it because they're in here. And it remembers when we change it because we're assigning this. It knows what this is. It assigns it somewhere. But none of that is visible. The only things that are visible are what our function is actually returning to the outer scope. Sorry, that's a roller coaster. That's like way out there, and I would be surprised if everybody's still even here. But that's closures, and yeah. Why don't if anybody wants to post anything? Oh, Kate solved the FizzBuzz project. If anybody is struggling with that one or the bean counting? Sorry, Karen. I'm just seeing the chat now. Uh, yeah, I think you were asking whether um, truthy negative numbers are truthy. Well, we can check that by let's just run node now. There's too much code. We do not -5. We get true. So -5 is truthy. So anything negative, anything positive, anything not 0 is truthy. Not infinity. That's truthy. Or negative infinity. Not a number. Not a number is falsy. So I guess 0 or not a number are both falsy. Okay. I guess ping me at any time about FizzBuzz and about the other project problem. And I like if you want to try it on your own, that sure. But I mean, we can also work through it if you get totally stuck. I wouldn't worry about it. The point is not to know how to get it right away. The point is to try to get it and to start trying to sort of think in that way and wonder about it, and then it'll make more sense as soon as you figure it out or as soon as you learn how it works. So yeah. Okay, let's do some easier, like this closure stuff is pretty crazy. But let's do some dice rolls. Let's go back to some Yahtzee. And then we'll probably end this in 20, 30 minutes. Okay, so from before we have an array of dice symbols. And what I said at the beginning, and I don't know who is here, but there's a Unicode you can look up on the internet, like Unicode dice symbols, and you get these things, and you can copy them and everything. But if you want your colleagues and people who don't have these symbols installed, like on Macs, they're all installed, but some people might not have them. There's an alternate way to do it, and you use one of these special backslashes. Remember, we had \t. That's a special way to say tab. well, you can do \u and then put numbers and they're hexadecimal. You can do 2A, 2B, and that's some kind of Unicode character. I don't know what that is. Let's see what it is. It's this thing. I don't know, some kind of strange division. But they're hexadecimal. They're 0 through 9 and A through F are all okay in these numbers. But the dice ones, if you look up on the internet, dice symbols, they're these 6 numbers. So we do /u and then the numbers for the 6 dice in order. And if we make a random number between 0 and 1, it's a decimal. We multiply that by 6, it becomes a random decimal between 0 and 6. And then we do what's called a floor, which is basically saying throw away all the decimals. So return the integer below or less than or equal to this number. We're going to get clean 0, 1, 2, 3, 4, 5. We're not going to get 6, I think, because it either doesn't return 1 or it's so unlikely it doesn't matter. And if we use those as indexes to our array, we map directly to the dice symbols here, which have index 0, 1, 2, 3, 4, 5. And then if we print that, we should see some dice every time we run it. So we have 1, 6. That's a little small, but these are dice. Hooray! Okay, so let's wrap this thing in a function here. Function roll 1 roll die. And we will return this stuff. So every time we want to roll a dice, we can just do this. We run it, we get the number back, we use that as the index to our dice array, and we can log the dice symbol. And it should be random. Yep. Okay. So let's extend this a little bit. With Yahtzee, we want to roll 5 dice for the first roll. And I don't know if everyone knows the rules, but you roll 5 dice. You can choose which of them to re-roll, and you do that twice. So you can say, I want to re-roll these 2 dice. I like the other ones. You re-roll those 2, and then you say, oh, okay, I want to re-roll just this one, and you can re-roll 1. And you can choose whichever ones you want to re-roll, and then at the end of 3 rolls, that's your dice hand, and it's sort of kind of like poker, like you try to get a score by having like 3 of a kind or 4 of a kind, or different special cases. I think there's a full house maybe or something like that. So let's change this function to say roll dice, and we'll pass it something called number of dice. This will be the number of dice we want to roll. It should be tabbed in a little bit more. We can do a for loop. We're going to say I is less than the number of dice. This is the common way we have of counting to a particular number. You start at 0 and you do less than. So we have our for loop. We need outside of this for loop because we need the scope to be visible for every time through the loop. We need our resulting array. We can do const rolled dice, and that's going to be an array. So we'll loop the number of dice, and here we will push rolled dice dot push, and we'll pass it our number. Instead of just returning 1, actually let's separate these on different lines because this is a little much to look at. So let's do const number equals this, and we'll push the number. And let's call this more than just number. Let's call this die symbol index, because this is going to be what we pass into here to show a dice. And then we return a rolled dice. Now, this returns an array, and they're not symbols. They're the indexes to our symbol array. So we can say const dice symbols equals. We will run roll dice. We'll pass it 5. And we'll get back our array of the indexes. That's what we're returning here. So to convert that into the symbols, just like before with the cards, we can do our map. And we'll say index, and we'll return dice symbols index. And this will turn into a row of an array of dice symbols. And then we can console.log dice symbols dot join. This is just like when we were showing the row of cards. And we join with the tab character, just like before. So if we log this, we roll the dice, we map them to symbols, and then we log. We see 5 dice. And every time we roll, there will be 5 totally separate rolls. And you could pretty much do the rest of the Yahtzee game scoring on your own. This could actually function, and let's do this because we don't have a whole lot of time left. Let's make this to be just the dice roller in our Yahtzee game. First of all, we don't need a whole tab. That's too much to look at. Let's just make it a space character. And we get our 5 dice. Okay, so we have 5, and we have we display the dice. That's pretty cool. At the top of this function, let's copy from our 21 card trick the exact same import for our prompt, because this is the only way we're going to be able to prompt. So we're going to say require prompt sync. And this is cool, but this is just one roll. So what our program should actually do is while true, and we'll quit our program with Control-C, so we don't need to handle any special input. We'll say console.log how many dice would you like to roll? And we're going to say const number of dice equals prompt. Actually, we don't even need this line. We can just put this right in our prompt, put a space, just like before, and get rid of this. So the first thing we're going to do is prompt, how many dice would you like to roll? and this, we don't know that this is a number. We don't know what the person is going to type in. So we actually maybe shouldn't call this number of dice. We'll call this user input. How many dice would you like to roll? Let's do const number of dice equals parse int user input. So let's, we're going to want to roll the number of dice they've asked for. And we want to make sure though that this is actually a number. This is not a number. And we also want to make sure that it's a positive number because you can't roll 0 dice or -5 dice. So we can probably do both of those by just putting a single if statement. If number of dice is greater than 0. Because I believe not a number, now let's check this real quick, but not a number greater than 0. It is not greater than 0. So not a number or any negative number or 0 is going to be false. And we will only roll the dice if this is true, which means we have a positive number. Now it could be any number. You could roll 1,000,000 dice, but let's not worry about that right now. We can copy this line, or cut this line, and just drop it right in here. And instead of 5, we'll say number of dice. Now let's split this up into 2 lines. So we'll make a new line here. We'll rename this variable to dice indices, and we will say const dice symbols equals dice indices dot map index to dice symbols of index. So this is a function again. Map takes an array, or this is an array. You run map on it. It takes a function. It runs the function on everything in the array, puts it into a new array, and gives you back that new array. And that will be an array of symbols. And then we can print, just like before, we print to the console those symbols. And that's really it, because we're going to keep looping forever, because this is Yahtzee, and all we're making is the dice roller. So, you know, you just want to be able to roll as many dice as you want. So when you roll your first hand, you can say 5, and then you can say 2, you can say 3, and you treat those as the dice you're newly rolling. And then, you know, you keep the score and all that separately. If we want to implement the scoring system and all of the interface for a Yahtzee game, that would take us quite a while longer. But that would be easy enough on a web page with the full web app. Okay. Whoops. Terminal. So I'll quit, and we'll say node index. Oh, and we have an error because we can't find the module prompt sync. Remember, we installed it. We had to do a special step to install it when we were doing the card trick. So when you see something like this, cannot find module prompt sync, one way to solve this is to just immediately do npm install prompt sync. And that's what it means. It's like, it's looking for some kind of module. And if you've copied some code, or if you're expecting to have, you know, be able to rely on this and it can't find it, well, you might not have installed it. So I did npm install prompt sync, exactly what it complained about not existing. So now if we run it again, it doesn't complain, it doesn't crash, and we can pass it the number of dice you'd like to roll. 4 dice, 1, 7, 500. That's pretty cool. 5, 9, 9, 9, 9, 9, 9, 9, 9, and it might crash. I guess that's a good place of any to call it a day. Ooh, look at this. This is a fun one. Whoa, we've done so much stuff. JavaScript stack trace. We've crashed the whole node V8. It has no idea what happened. Good job. Look at all this stuff. So this is, here we go. Here's some V8 internal stuff. This is what happens below the JavaScript. When you run the JavaScript, it says, this is some C++ or something code, and it's saying, internal heap fatal process out of memory. We ran out of memory because we tried to roll so many dice. Internal heap allocate raw with retry or fail. So here's what's happening. I mean, this is sort of a little window into the internals of what happens when you run JavaScript. There's a program below it which is saying, hey, I need some memory for my string or for my uh, array or whatever it is, and it's growing and shrinking that memory and moving it and doing all this kind of stuff for you by calling all of this stuff, which is written in a lower level language and is very just verbose and fun. Look at this: grow capacity, new fixed array with filler, allocate raw with retry. So, I mean, we didn't really go into like formally what this is doing. I think like there's an opportunity maybe in week 9, but we'll have to maybe do a session on what is JavaScript doing. Underneath when you run JavaScript, what does that turn into? It compiles into this, and eventually it switches inside the computer. But we could go all the way down that stack maybe one time. Anyway, uh, we can probably roll 10,000 dice or 100,000 dice, but it takes a while. And definitely you don't need that many for your Yahtzee game, so this will work very well. Okay, I don't know if anyone's still here. Have an excellent afternoon.
Still here.
Okay, I hope I didn't totally lose you with that closure stuff.
No.
Okay. I mean, that was a little straight a little bit from, what we did in class explicitly, but that should give you an idea of, what keeping a value inside the function does, and, why you maybe would use that. It's to be able to have these little modules. And in fact, before there was node modules and before everything was modern modules, that was the only way to encapsulate, to keep something, in one section of your program that things could interact with, but had private values or access rules. So I mean that used to be much more common than, you won't see that kind of thing much today. But that's what a closure lets you do basically.
Cool.
Anyway, okay, well, yeah. Hey, thanks for stopping by. Happy Easter if anyone's doing that. I'm gonna go see my grandparents and have some food, I guess. And
cool. Thank you so much.
Yeah, and ping me with any questions, anything about FizzBuzz, and Max will pick it up tomorrow, and you're gonna have a good time. He's got a whole lot of fun new things, and I think a lot of it's on free code camp, so there will be some really good ways to sort of just do interactive demos and things like that. So that should be great.
Cool. Thank you.
All right. Bye.
Have a good one.
Cheers. You too. Bye. So long, stream.